Hey folks, Professor Gray here. Ready to talk to you about two-proportion z-test in hypothesis testing. Previously, we talked about independent samples and dependent samples. Well, there are three types of hypothesis tests that involve two samples of independent data. Or at least they're the ones we're going to cover. And the first one of those is two-sample proportion test. Then we'll talk about two-sample z-test and two-sample t-test. So two-sample proportion tests are first. Here's some notation for two proportion tests. P sub 1 is the population 1 proportion. N sub 1 is the size of the first sample. X sub 1 is the number of occurrences in sample 1. P hat sub 1 is the sample 1 proportion, and Q hat sub 1 is the complement of P hat sub 1. Corresponding notation applies to population 2 and sample 2. So for example, for the population 2 proportion, I would have a P sub 2 instead of a P sub 1. So the subscript 1 and 2 is there to denote where the information is coming from. My first set of data or my second set. For a hypothesis test involving two proportions, we use a two proportions z-test that uses a normal distribution, thus the use of the z, and the test statistics shown on this slide. The calculator command that's used is 2prop_z_test. Let's do an example. Do spending habits depend on the type of money people have? Well, 89 students were randomly assigned to two groups and given either $1 in quarters or in paper money. They could then keep the money or buy gum or mints. The outcomes are shown on this slide. Let's test the claim that money in large denominations is less likely to be spent relative to an equivalent amount in smaller denominations using a 1% significance level. The first step in this hypothesis test is to identify the type of test that's being used. This is a two proportion z-test. The next step is to identify the hypotheses and label the claim. As usual, we'll have H sub 0, the null hypothesis, and H sub 1. Some textbooks use H sub A for the alternative. H sub 0 will use an equal sign. And since we're testing proportions, the null hypothesis will be that P sub 1 is equal to P sub 2, or that the population proportions are the same. In the alternative hypothesis, I use the same symbols, but I need an inequality between them. Let's let the sub 1s be the data from those who are given a $1 bill, paper money. Let's let the sub 2s be data from those that are given for quarters, or change. So in this particular claim, the claim is that money in large denominations, that would be the dollar bill, is less likely to be spent relative to the same amount in a smaller denomination. So the symbol for H sub 1 would be less than. And this is also the claim. I label that using a C in parentheses. This will come in handy later when I interpret the results. The next step is to find a test statistic and the probability of the sample data occurring under the assumption that H sub 0, the null, is true. For that, I'll use a calculator. In my calculator, I go to Stat, Test, and 2prop_z_test. Now I've got some blanks to fill in. X sub 1 is the number who spent the money from the first sample. N sub 1 is the size of the first sample. Similar numbers go in for the sub 2's. On the next to last line, I'm going to match up the inequality in H sub 1 with the inequality in my calculator. Then I'm ready to calculate. The z-score is the test statistic. The p-value underneath is the probability that I'm looking for to compare to the significance level. For the next step, I'll compare this p-value to the significance level and either reject or fail to reject the null hypothesis. In this problem, my significance level, or alpha, is 1%. I can add extra zeros to alpha if that helps me compare. Alpha is bigger than p, so we reject the null hypothesis. The last step is to interpret this hypothesis test outcome in terms of the original claim. My claim was the alternative, and I rejected H sub 0. So we would say that we support the claim that money in large denominations is less likely to be spent relative to an equivalent amount in smaller denominations. That's our hypothesis test from start to end.